Okay, so I'm teaching you how to name polyatomic ions using the 3-4-4-3 trick. You have a special periodic table that has this numbering system on the non-metal side, okay, the 1, 2, 2, 1 row, 2, 3, 3, 2, 3, 4, 4, 3, and then it has the endings and stuff like that associated with it. So let me explain what this is for. When you have oxygen attached to one of the non-metals and they end in 8 or 8, you're going to be using this numbering system, okay? You don't have to really memorize all of these polyatomic ions because you can use this trick. So I'm going to go ahead and start out with the 3, 4, 4, 3 row of numbers. So what does this mean? These numbers are the subscript on the oxygen or the number of oxygen attached to the nonmetal above them when they end in 8. So if you have something like the phosphate ion, that means you have phosphorus with oxygen attached because it ends in 8. So you go to phosphorus over here, PO4, because this is the number of oxygen attached when it ends in 8. So PO4 and a -3 charge. That is the formula for the phosphate ion, okay? If I'm talking about the sulfate ion, the sulfate ion would be sulfur with oxygen attached, and it ends in 8, so I'm looking here at this row. So SO4, that's the number of oxygen attached to sulfur, and then the charge would be a -2. So SO4, -2. If I'm looking at chlorate ion, okay, the chlorate ion contains chlorine, so I come over to chlorine, ClO3, -1 is the formula for the chlorate ion. Okay, so this works for carbonate, CO3, -2, bromate, BrO3, -1, iodate, IO3, -1, okay? Even silicate, SiO3, -2, or selenate, SeO4, -2. The only one that doesn't follow the group that it's in is the nitrate ion. Okay, so you have a circle around nitrogen and it goes over to this group because it wants you to follow the numbering system for group 7A when oxygen is attached to nitrogen. If oxygen is attached to nitrogen, then you're going to say, okay, nitrate would be NO3, -1. Okay, but if nitrogen does not have oxygen attached, you stay where it is. Nitrogen would have a -3 charge. Okay? Okay, now I'm done using the 8 row as an example. Now if I drop one oxygen from the 8 row, I come here to the 2, 3, 3, 2 row. That means I'm ending in 8. So if I have something like the phosphite ion, PO3, -3 is the formula. If I'm writing the sulfite ion, that would be SO3, -2. If I want the chlorite ion, that would be ClO2, -1. Okay? Remember, if you have nitrogen with oxygen attached, it's ending in 8 or 8, and that's why there's a circle around nitrogen. You have to use this numbering system for group 7A. So nitrite would be NO2, -1. Okay? And if you're doing bromite, BrO2, -1, carbonite, CO2, -2. All right, now, if I lose one more oxygen from this 2, 3, 3, 2 row where the ites are, I get something called a hypoite. So hypo would be the prefix, and then ite would be the ending. Now, if I'm writing the hypo phosphite ion, that would be PO2, -3. If I'm writing the hyposulfite ion, that would be SO2, -2. If I'm writing the hypochlorite ion, that would be ClO, don't write the subscript 1, -1. If I'm writing the hyponitrite ion, that would be N. You come over here because there's oxygen attached, O1, but we don't write the subscript 1, -1. Okay, last one. Let's go beneath the 8 row and look at the per 8. So there's a little typo on your periodic table. It says per 8. Make sure you correct it to per 8. Okay? 4554 is the per 8 row. So per is going to be the prefix, 8 will be the ending. So if I want to write the per phosphate ion, then it would be PO5 -3. If I want to write the per sulfate ion, it would be SO5 -2. The per chlorate ion would be ClO4 -1.